Welcome to this presentation brought to you by Astronics Test Systems and the Freedom brand of communication systems analyzers. I would like to thank our partner EPCOM for helping us arrange this meeting with you today. The topic of this presentation today is testing live DMR repeaters and testing DMR radios. All the phone lines are in mute, and if you have any questions during the presentation, you can write them down on the right-hand side of the screen. Please type your questions there, and at the end of the presentation, we will try to answer some of your questions. We're also including a few PDF documents. I have 5 PDF files that I attached to a window called Handouts. It says 505. You can download those PDF files directly, and they're all related to live DMR repeater testing, duplexer testing, combiner tuning, and other areas that you may be interested in. These documents can also be found on our website, and I will talk about that later on. At the end of this presentation, you will also receive a copy of this presentation for your future reference. And this presentation is divided into 2 parts. The first part will be theory about DMR and how the technology works. And the second part will be an actual demo with a DMR repeater. And we're going to also connect a live radio, and we'll show you some of the screens on how to test these different units using our product. Let me introduce you to the people who will be doing the presentation today. First, I would like to introduce you to my colleague, Jose Julio. Jose Julio is an electrical engineer, an MBA specialized in project management. Jose Julio is based in Sao Paulo, Brazil, and he's responsible for sales and technical support throughout Latin America. I call him JJ. He's my good friend. I know him for about 12 years now. Jose Julio and I, or JJ, has 25 years of experience in the wireless telecommunications industry. He has been working with different multinational companies during the last 10 years, in some of the largest LMR companies in Latin America, including Motorola Solutions, Harris, Tate, and ICOM. I'm Luis Riano. I'm going to be one of your presenters today, and you can find our emails on the screen. If you have any questions after the conference call, you can email us directly. During this presentation, we will learn what it means to test your DMR radio infrastructure in live mode and in test mode, and when to use each one of those options. We will review when you should test the system over the air or take it out of the system, out of service for testing. And finally, you will also gain some understanding on how to set up your test equipment to perform over the air and bench live testing. How is this presentation structured? First, we're going to talk about a customer who used his skills in testing live DMR repeaters to quickly verify system performance without service interruption. Next, we're going to review the basics of DMR radio systems and take a quick peek under the hood at the digital protocol that makes it possible. Finally, we're going to discover the best practices for selecting the test method, setting up the test equipment, and performing the necessary steps to be able to test the system thoroughly. Could these skills help you save time and money at your company? Something similar to this happened to one of our customers, Mark, at a large utility company in Texas. Several radio systems users were experiencing problems accessing the system in one area, and they were having problems with their radios, with their portable radios. A major storm had caused widespread outages to the electrical infrastructure, and Mark, in this case, he needed to find the problem and fix it quickly. Using his Freedom R8100 analyzer, he performed some tests. He confirmed that the system sensitivity was poor by testing the live repeater over the air. During his visual inspection of the radio equipment, he located the faulty cable. He was able to swap the cable without taking the system off the air, and he was pleased because the test equipment could perform this live test over the air, and without it, the system would have had to be offline for a long period of time during his testing. Mark's understanding of the DMR radio system and his test equipment helped him analyze and respond to the situation in a matter of minutes. What is DMR and how does it work? Digital mode radio, abbreviated DMR, is a limited open digital mode radio standard defined by the European Telecommunication Standards Institute and used in commercial products around the world. DMR, along with P25 Phase 2 and NXDN, are the main competing technologies in achieving 6.25 kilohertz equivalent bandwidth using the proprietary AMBI+2 vocoder. DMR and P25 Phase 2 both use two-slot TDMA in a 12.5 kilohertz channel, while NXDN uses discrete 6.25 channels using frequency division, and Tetra uses a 4-slot TDMA in a 25 kilohertz channel. The primary goal of the standard is to, number one, specify a digital system with low complexity. Number two, provide a low cost and interoperability across all brands. And number three, make sure that radio system purchases are not locked into a proprietary solution. So that's the benefit of the DMR technology. In practice, of course, many vendors have introduced proprietary features for each of those radios or technologies that make their products offerings non-interoperable with other brands. And that's what we need to be aware of as we test these different settings or features. What you see here on the screen are some of the technical specifications that are very important for DMR. And although not strictly necessary for testing, I mean, you don't need to know these things to be able to test the system. It's important to have a knowledge of the basic underlying protocol details, because they can provide insights for interpreting your test results. And this list can also give you a good reference to look at the key values derived from the standard and what you're seeing when you test the network. Overall, this is very helpful to gain a deeper understanding of the subject, and that's why we'll share this with you, but I'm sure you have seen this before, and these are some of the key aspects that you need to take into consideration when doing your testing. Now, when we talk about the standard for DMR, the standard defines three tiers of DMR service. Tier 1 provides only direct radio-to-radio communications without any system infrastructure needed. And Tier 2 provides conventional systems using radio repeaters, and each repeater provides 2 transmitter receive pads, one in each of the 2 time slots, using only a single frequency pair. Tier 3 provides trunking systems, and each side contains a controller with a control channel and a number of individual base station radios to provide the voice data channels, which are dynamically allocated on a call-by-call basis. Each base station provides 2 channels, one in each slot. So if you recall, when we were talking about DMR technology uses TDMA with 2 slots. So keep in mind that some manufacturer systems are not DMR2 or DMR3 standard compliant. And also remember that some of the radio features from one vendor may not interoperate with the other vendor systems. So that's also part of the industry and part of the technology. Now, this presentation is going to focus on Tier 2 and Tier 3 systems. And as I mentioned before, what we're going to do here is we're going to test, we're going to do a demo using one of our units. Jose Julio is going to connect his unit in Brazil using the 8100 to connect to a DMR Live Repeater. And he's also going to do some testing with a subscriber unit. But the idea is that with this presentation, we're going to talk about Tier 2 and Tier 3 systems, since they use radio infrastructure to provide communication services. The base station and / repeater can provide one of 2 modes, live mode or test mode. So each mode must be tested differently, and it serves a different purpose. For example, in live mode, that means that the base station is operating as a repeater, and it is listening for a DMR signal at the receiver frequency and sending that signal out of the transmitter frequency. If there is no received signal for a period of time, the transmitter stops sending out the signal, and once the system it goes into sleep mode, the received signal must have a wake-up sequence to re-enable the transmitter. And that's what the 8100 will do. It will basically mimic that wake-up sequence to, let's say, lift up the communications or enable the communications with the repeater again. The test equipment in this case has to be able to generate that sequence. And in this mode, the repeater can be tested while directly connected to the test equipment. It could be on the bench or it could be over the air. Over the air testing can can verify that the repeater is functioning as a repeater, but may not be able to determine how well it is able to perform this job. For example, accurate power output and receiver sensitivity measurements may not be possible unless the base station is put into test mode. And that's the other sequence, or the other way of testing the repeater. In test mode means that the base station is no longer operating as a repeater, and the system is not able to provide communication services while it's in this mode. Its receiver and transmitter operate independently under the control of an attached PC or through the front panel controls of the repeater. The manufacturer provides software that can be used to enter the repeater into test mode to control the parameters of the base station. Once the test equipment is connected directly to the base station, then the manufacturer's service manual procedures can be followed to fully test and align the hardware. In this mode, the test equipment does not need to send the wake-up sequence that will be required in live mode. In summary, live mode testing is for quick functional verification and can be performed while the system is on the air. So if you guys are going to do preventive maintenance, or if you guys just want to do a spot check on a site, on a base station, or maybe somebody reports an issue with the unit, with the repeater, then you can take your R8100 or R8000 and perform these tests on live mode. Now, I would like to make sure that you guys take a minute to digest this information and review this slide to make sure that you clearly understand when you would use each one of those different sequences, because that's going to basically define how you use the product and the benefits that you can gain out of it. So how do you connect the test equipment and set it up for performance to be able to perform the necessary test? That's what we're going to see next. And here's what we're going to do. I'm going to hand it over to Jose Julio so he can do his live demonstration using one of the repeaters that he has in his office in Brazil. But focusing on live test mode, consider the live scenario which lends itself to over-the-air testing. For example, let's say you're responding to an end-user complaint and you have to drive to the site and you don't want to take the system offline. And let's say you have the 8100 sitting with you in your car, so you can get close to the unit, close to the site, and using the connecting an antenna through the RF generator output and the antenna port, you can actually set up the instrument to communicate with the base station and make some measurements, some parametric measurements to verify that the system is running correctly. So how do you connect the instrument to the system and set it up for testing? That's what Jose Julio is going to show us in the next part of the presentation. Jose Julio, I'm going to make you a presenter now.
Good day, everyone. Thank you very much for being here in this presentation. So what you guys are seeing on my screen is a remote front panel. It is an option that you can download on the page and set up on your R8100 and to your equipment. This allows me to connect and control the R8100 by the computer. Okay, let me show you real quick my camera here and show how is the setup I'm using in the office. All right, couple of minutes. Okay, so I have the rig here, connect on the R8100. I have two antennas, one antenna on the antenna port, another one on the RF port, and the repeater is here. That's a Motorola repeater. Okay, shut down here and going to the presentation. All right, so before get starting, I want to show you a real quick information on the screen here. So how the screen is set up and how can you understand each one of those parts of the screen. So the equipment R8100, the screen are divided by 4 zones. I have RF zones, audio zone, and display zone, and meter zone. Those zones could be reached by the buttons on the left, on the right here, on the right hand here, or you can go directly straight on the keyboard, choose a number 1. This is a zone, RF zone. Number 2, it is display zone. Number 4, audio zone. And number 5, power meter zone. Okay. For this test, as mentioned on the presentation, we said we should take a couple of parameters to set up the equipment to reach the repeater by the air. So two most important parameters are the frequencies. So I have to enter here the monitoring frequency and the generator frequency. So the monitoring frequency is the frequency that the repeater is transmitting right now. For this case, I'm using 380 repeater, and then I have a 360 025 for reception. Okay, enter. Actually, I have to choose the monitor port for this reception. So we are using the antenna port, like I show you on the camera and show it at the Luis presentation too. Right away, I have to go to the generate mode. On the generate mode, I have to enter the frequency that I will transmit, or reception frequency for the repeater. Let me pick here 365 025, enter, as well as the output the generator port. Which one will be choosing here? Using the generator or out. Choose the generator out. Now I have the link between the R8100 and the repeater over the air, using the two small antennas. It shows at my camera minutes ago. All right, then I choose duplex mode. It means that the R8100 is transmitting and receiving through those ports I choose before. Like I said here on the display, I have a monitor frequency 360 025, generator frequency 365 025. I'm using FM. Oh, FM. We are testing a DMR. So what should I do right here? So I have to change my test mode from the standard or analog to digital. How can I do this? Go to test, escape, test mode. Down below here, you see some tests that's possible for this unity. Standard or analog, DMR, P25, P25 tracking, NXDN tracking, Tetra base station, Tetra DMO, Tetra TMO, DPMR, P25 phase 2, PTC, and the newest avionics. So let's go to DMR. You will see that as soon as I choose DMR, you see that on the audio zone becomes a DMR zone. This is DMR zone, show you and allow you to add some features on the frequency on the equipment to reach the right setup for attach the repeater. Okay, so let's go here. A quick view for this short screen. So it's I can see the synchronism. I can see the test pattern. I do have the color code, search radio ID, or the ID I'll be using for reach the repeater. Actually, some responses such as a symbol deviation or SRE, symbol rate deviation to frequency error, magnitude error, and bear test. Okay, so in this session, we can take some ports here and put some information and check what we can select to allow the R8100 to reach the repeater. Okay, we are in duplex mode. The UUT or unit under test. Right here we have some possible tests. We can do a MS test or mobile or portable test directly on the R8100. You can do base station tests attached physically on the R8100, and the repeater live repeater test that you can use over the air connections. So let's choose these conditions here. When you choose this, some of options here can change, and you have to double check if you using the repeater live. Okay, that's okay. Back here to some other parameters. I'll have to add the color code, but right away we don't know the color code. I have here in my hand a portable radio, a DP4550. Let me do a PTT and set the repeater. Okay. Check the repeater. Okay. I can't see anything else, but why? Because I forget something. Let me see what I think. I have to test pattern and have to check the sync pattern. We are sync on the voice. We are using voice. Then we have to choose BS source voice. When I choose this and press the PTT, then I see the synchronous, I see the ID from my portable, and I see the color code. When I take this color code, let's pick this color code and copy it directly on the generator with using this key. Then I have color code copied at my generator. Let me adjust this visual information to have you guys more easier see for the spectrum. Okay, 40 I think, -40. Okay, now you see the whole signal on the screen. Okay, let me release the PTT here, and let's using the R8100 to reach the repeater wireless. Okay, let me see everything set here, checking the parameters. Okay, all done. Back to the DMR zone. Back to the DMR zone, check the modulation mode and test patterns. When you choose test pattern, you see some patterns that you can use for calibration, even the radios or repeaters, and then you have to check the owner manual and check what one you're using for calibration. Right here, we are using 1031 tone because we are synchronizing by voice. Then we generate a kilohertz tone, 1K tone through the R8100, pass to the DMR modulation and receive on the radio. Let's choose this one and see. Remember I told you guys in this small blue market screen, some information appears. So test pattern of 1031 tone. You have to pay attention. If you're missing something, you can just look at in this point and see what you are missing. So anyways, let's check here. Have tone done. Let me put the repeater on air. Continuous mode. When I choose continuous modes, what's happening? The repeater start synchronous, and you heard a tone, 1 kilohertz tone on the portable. This is transmitting by my R8100. R8100 are using our interface to connect it to the repeater, and then you repeating this information on your portable radio. With this, we should take some other readings on DMR screen. And DMR screen shows here what is showing us. Search radio ID. The radio ID from my R8100 is 60,770,060. This is the last number or the last ID possible on DMR operation. So this is radio ID or group ID. I'm sorry. Actually, you see the symbol deviation. The symbol deviation for this is 1953, 1950. On the mark is of 1944. I show you later. Actually, other points in here. So let's take this information and do a very quick test for sensitivity. The sensitivity, you test your antenna. So we are transmitting here -50 dBm by my R8100. Let me back to the generator screen. Okay, let's using the output level here. We have a -50. Let me reduce this for -60. Then the signal goes -70. The signals disappear and the synchronism gone, and the signal goes down, and I don't have the repeater attached, and I don't have any other transmission for it. So let me back this for 50 or 40. 40 is okay. Enter. With this quick test, actually you can test the sensitivity and the error bit or bit error. Let's go back to the DMR section here. So in the DMR section, you can choose bear test. Start the bear test, start. And remember the rule for the DMR. It says that if bear goes up to 5%, you start missing some packages and something like that. So let's reproduce here this condition. Back to the generator screen. Choose the output level. Let's reduce the output level to 50, 60. You see the bear test, you know, gone. 20%. 20% means that you missed the information. So right here we are, let me reduce this for a minute. Okay. In this case, you miss the synchronism and signal is gone. Okay, in this case, what's happening? So we are using the repeater and on the site, and suppose you are sit on the car close to the repeater site using external antennas on R8100. Then you do a quick test. So, for example, you don't have retransmission from the repeater, and then you do this quick test and check, hey, I have loss, I have bad sensitivity. Maybe my antenna is bad, maybe some cable is broken, or maybe I missed the calibration on my duplexer, on my receiving equipment, and so on. So this is a quick test that you can do and check everything else close by your site. Then you send someone there and check. Anyways, let me back here for the number, the good number, 50. Oh, sorry, 050. Enter. Output level -50. -50. Okay, I have the signal on, synchronism on, and the information here. So let's see this information on display. How can I do that? I choose the display zone right now and check some. I can select some display to show what we can see here on the digital mode. Let me take this eye diagram. This diagram shows you that the equipment is tuning on the right frequency, as well as the symbols as passing through or changing from the one by other. You know, remember Luis mentioned about the 4FSK modulation. So you have a F0 or a frequency programming. Example here, 360.025. and the symbols are shifting up this frequency and above and below this frequency, you know, in parts of negative 9044 minus or plus 9044 minus or plus 6048 kilohertz. So those transactions means each symbol can carry 2 bits, and those 2 bits can do the signal you're seeing here on display. Okay, so let's see what we can see also. A power profile. A power profile is a level that you're receiving on the R8100. Okay, what the repeater are sending to you. Okay, right here we are receiving negative 47 dBm. Okay, let me see on the power profile, and let me change the scale here to make it possible you guys see this information on the screen. Here negative 50, negative 40, negative 47 is around here on this yellow mark. Okay. All right. Let me see that. Let me show you what other point here. The distribution port or distribution plot. The distribution plot is the plot that is generated by this signal 1031. This one is distributed right here in this way. You can see the distribution plot here and the constellation down below. You see, the symbols are split through the center frequency, as you see over here, around negative 625 kilohertz, around the negative 19 something over here, and around the plus 6025 kilohertz, around the plus 1947 or 7 something here. So, but we have more accurate details, or you can do a detail analysis for this information. How can you see this? Take this information. This is the symbols made by the rule, okay, negative 1944 and so. This is the measured deviation we are measured from the repeater, and this is the magnitude error for this repeater. Let me put the repeater in silent mode right here. 1 minute, please, back here. Okay, modulation mode off. Let me take the repeater by the portable. You see the magnitude error change a little bit. 1 minute, please. Okay. You see this difference? So this rig is, I don't send any information, so just noise or something else. So this is quite different, but it shows that you have different things from the repeater. I'm sorry, from the R8100 and from the portable radio. Let me put this back through the R8100. Modulation mode continues. Okay, there we go. All right, this is good. All right, this information should be sent for someone. For example, you have to check the health for the repeater, and how can I take or take this screenshot and send it for someone. R8100 has a feature that you can use a USB driver, put a USB driver at the USB port and choose and press Shift 0. As soon as you press Shift 0, a screenshot from this is passed through a folder inside the pen driver, and then you have this information to show a report or something like this. Okay, let me show you another important things here. Okay, you see encoder configuration. When you choose encoder configuration, it shows you what the configuration to encoder transmission for DMR. So you see the ID we are using, okay? We see we can generate by the R8100 emergency signal like this and check if this emergency appears over here, you know, from the protocol details. On the protocol details, seems that the slot we are analyzing is number 1. We don't have any priority. The synchronous slot is number 1. The emergency is generated by the R8100, and this is the call target address we are using. Back to the emergency signal, back to the DMR screen, back to the encoder configuration, remove the emergency. Okay. Suppose you choose another slot. Let me take slot 2 over here. Take slot 2. The information on the portable disappear, but if you check the signal on the screen, is still on air. You see, it's still synchronous here. It's still the pattern, still color code, information ID, and everything else. But the radio are programmed for the slot 1. So all communication is taking the slot 1 way or path to transmit. Let me back to the encode configuration and select the slot number 1. Back to the audio on. Okay, Luis, I think I'm good for here.
Thank you, Jose Julio. Thank you for the information you share with us. I have here in my on my screen, I have the 8100 also, and I'm using the remote front panel like Jose Julio was using just now. I have a DMR radio connected to my unit, and a lot of times you get a batch of radios that need to be tested very quickly, and you need to do a go-no-go testing on those radios. Sometimes you know exactly how the radios are configured, and sometimes you may not even know how the programming was done. So in order for you to be able to find the frequency where that radio is transmitting, you can do an RF scan. It's very simple to do. Right now I'm in analog mode, as you can see here in the audio zone. It says audio right here. That's the analog format. But I could go into digital mode. But I want to show you either way this operation works with either one of these measurements or technologies that we have here. In this case, I'll go into RF scan, and since I don't know exactly how this radio is configured, let's say I'm going to scan from 100 megahertz to 600 megahertz, and I'm going to do a single scan. So let me turn on the radio first, of course, and I'm going to do a single scan. So right now it's scanning, and right here I found that this radio is transmitting at 433.5 megahertz. So I could go back here to my RF zone and then copy that frequency to my generator. I could release the PTT, and let's say I want to go into DMR mode. Let me go into DMR mode real quick. And let me switch it to channel 2. I have the digital channel set up over here. As you can see, if I had it in analog mode, I wouldn't be able to decode the color code, but because I switched to digital, I can see that the radio has synchronized with the subscriber unit has synchronized with the 8100. I can see the basic measurements. I can see the source ID and the color code. There are different things we can do here with this radio. We can also test, like Jose Julio was showing us before, we can do the display selection, and we can look at the distribution plot. We can also look at the eye diagram. So these are basic tests that you can use to double check and see if your radio is operating correctly in a matter of minutes. So that's one of the benefits. Of course, we all want to do, besides being able to test the radio manually, we want to be able to do auto-tune. So to be able to perform an auto-tune on a DMR radio, you would press test, the test button right here, the blue one. You would select the third key, auto-tune. When you get to auto-tune, you can choose the name of the name it, make and model that you have there. In this case would be Motorola Portable. And then once you select the radio that you want to test, the first thing that the unit will show you is a block diagram on how to connect the unit, the radio, the subscriber unit, to the power supply and the audio breakout box, and how it connects into the analyzer. Once you have all the connections set up correctly and the switches on the audio breakout box, according to what it says here on the bottom of the screen, you can hit return. And here you can select either you want to do a test only or a test in a line. If you do test in a line, of course, you have more things that you need to test and verify and align properly according to the manufacturer's requirements. And if you go over here to the second page, you can also look at the test limits that the manufacturer is requiring for these tests. We work with all the different manufacturers to create these auto-tune setups. And if you need to make your setups or your script a little bit more strict, you can change the limits. You can edit the limits over here and make it read something that is tighter or that it goes in line with what you want to see in your network. You can save those changes as a separate file, but the original template that we recorded on the unit that comes with the option is still there. You can go back and say low default test limits, and we'll go back to the original. You also can get the test results. If you go here to test report, you can see a test report. It's a CSV file that is saved inside the unit. You can export it using an external USB connected to the unit, and you can print it using Excel or WordPad. Now, another thing that I would like to show you before I close the meeting today is how to look at the options that you have on your unit. So in order to get to this menu, I press the button that says settings here. I went to options. In options, you're going to see all the options that you have enabled on your unit. Our radio is our 8100 is a software-defined radio. So all the options are already embedded, all the hardware is already embedded in the unit. If you want to enable any of these options, whether DMR, NXDN, P25, or Tetra, you would place the order. We would send you a 16-digit code. You enter it here using the keypad on the unit, and then as soon as you hit enter, it would activate that option. Here we have the auto-tune and different options and different manufacturers that we work with for auto-tune. We have a new software release, either 3.9 or 4.0, that's coming out in the next couple of weeks. And that one is going to have new features, and those software updates are free of charge. So you can go to our website, to freedomcte.com/upgrades, and you can look down the list and look at the different software updates that we have up there to make sure that your radio is running the latest software update, because that's going to help you also make sure that you have correct measurements and the most accurate information. So right now, for example, I have version 3.8, which is the latest one in the market. But once it comes out, you would use, when you go to our website, where I mentioned before, freedomcte.com/upgrades, each software update also comes accompanied with, it has a document that explains, the procedure to load the software. So make sure you read that document before you upgrade the unit, and you have to go one step at a time. If you have a very old software release, you can't jump from the old one to the newest one. You have to do it in steps. So you have to go each one one by one to get to the latest software update in the market. And the other thing, of course, what we're doing here, we're using the remote front panel. we're using a DHCP, or you can use a fixed IP address to connect to the unit. And all of these things are extremely useful for technicians and engineers like you in the field. I think another thing that I wanted to show you maybe before I forget, some of you guys also need to do service in the field and maintenance, preventive maintenance to fix issues or to test duplexers and combiners from time to time. So if I go here into test mode and I select standard, let me go back to instruments, and I'm going to use my tracking generator to test this duplexer that I have connected over here. So the first thing that I'm going to do is I'm going to put my center frequency over here, which is 452.0, I'm sorry, 525. Okay, and then let me go to my number of points. I'm going to use 301. You can go from 100 all the way to 600 points. I'm going to use my narrow. You can use different types of resolution bandwidth, wide, medium, or narrow. Then I'm going to go here to select marker type. I'm going to use vertical bars. I'm going to select marker. Let me go back here and select market mode. I'm going to use delta. When I select marker 1, I'm going to select the frequency. In this case, let's see, 455.025. And then let me go to number 2, marker number 2. Let me select value here. The frequency for this would be 450.025. Okay, and one of the things that we need to do, of course, is change the output level to 0 dBm. And let me increase the attenuation here to 26 dBs. Another thing that I need to do here is normalize my measurement. So in order to normalize, I will go to disconnect my cables and connect a barrel between the two. And I will go to normalize in this case. I'm going to zero out the readings that I have here to have something more accurate. Now it's zeroed out. Let me reconnect the cables again, one going to the generator port and then the other one going to the antenna port. And so here we're looking at the high pass, and we're looking that we have here, I don't see the delta here right now, but we probably have around 70 dBs of isolation between the pass and reject. And of course, you guys can get more information out of this than I can show you here. But I'm sure you understand what I'm trying to show you in terms of the benefits that you can get from this unit. If you want to save this file that you have here on the screen, you can click here where it says Shift and 0, and it automatically. I plugged in a USB memory stick to my on the 8100. It's going to give you this warning. You can just hit continue, and right now it's sending that screenshot to your USB. And after that, you can just take it out, and then you can save that for future reference in case you need to do a report. You need to prepare a report for your boss or for somebody in your organization. And this information could be useful for future reference. If you need to send somebody else to do preventive maintenance, they can verify how you set up the unit. Like here's the JPEG or the bitmap, the JPEG that I got from this measurement. And so you can use this for reports, or if you need to do an audit, or if you need to go back 6 months from now and verify if there's been any discrepancies or any movements with the original measurements. And so that's very important. Now, let me go back to the final part of the presentation. But by now, I think that it is very clear that having a test equipment to test your units and your test your subscriber units and the infrastructure in your network is very important. And performing live repeater mode tests provides valuable feedback and is a quick tool to verify the system functionalities. The ability to perform this verification over the air enhances your maintainer's availability to check the system without having to interrupt the entire network. So I think with products like ours and the ones that you already have or you're planning to buy, you will get all these different tools to make your life easier and to be more profitable. We can also stay in touch with you guys. If you have any questions, we can support you with training. If you want something more in depth, you can contact your representative from EPCOM, and we can help you troubleshoot the problem or help you navigate the situation with your unit. So we have a full suite of DMR tests that you can use. We also have loopback, voice loopback, and we align ourselves with all the different manufacturers in the network, in the industry. If you go to our website, to freedomcte.com/library, you're going to see a whole bunch of different documents, including the ones that I mentioned here that I attached to the area that says handouts. I have 5 documents there. You're going to see how to perform DMR measurements on live repeaters. And this is my last slide for today. I would like to thank you for your time. I would like to thank also our rep, EPCOM, for bringing you guys together to this meeting. On behalf of Freedom and Astronics Test Systems, we trust that you have found this information useful. Please stay safe and look forward to hearing from you again.